Okay, so we are coming from a different world than our previous colleagues here. So Martin and me, we are coming from the largest group in this area, the largest producer, the largest retailer. So these businesses are pretty traditional, right? These businesses are here for 100 years, for decades, for 60 years, it depends. So they are not like startups, Googles, and similar businesses, but still we have a need for AI, for machine learning in our everyday operations, and we're going to present how do we do that. Here you can see that basically we are very significant with a lot of employees, with a lot of consumers, revenue of 5 billion, EBITDA of almost $500 million. So a very significant business. Both Martin and me, we are coming from the retail part of the business, which is roughly 60% of total business. Martin, he's coming from Mercator, Slovenia. I'm coming from Konzum, Croatia, and we work together in this project that we are going to present here, and how do we use it in the business. We heard today it is really, really important to use the machine learning in order to create the value for the business, and this is also our mission. So, as our previous colleague here, we also interact a lot with our consumers. We have very, very impressive numbers, especially for this region, right? So our retail, we have 2,500 stores throughout the region, and we interact with many consumers, 4.6 million consumers per month. They do a lot of transactions, hundreds of millions of transactions. Many of them, 1.8, have loyalty cards, so we track the data that is collected through the usage of this card. Of course, it's aligned with GDPR, so it's anonymized. We don't use any personal data. And although we are traditional, we have an online channels, so it's business going up, especially in the last couple of years. It speeded up. The growth was speed up, and we have a lot impressive numbers there. So beside that, we interact with our partners, we interact with our employees, and all of this is supported with various BI systems, and a lot of data stays behind as a result of these interactions supported by BI systems. So we are definitely data-rich company. We have 30 terabytes of data, and of course, each of these companies is always using a data or information to come to decision, but we really want to boost it to another level. We want to make this data usage seamless in everyday decisions, all the way to the rare decisions, strategic decisions. So we want to use our data, and this is our strategic goal. As a matter of fact, it's a strategic goal of a company in our digital transformation strategy, and as a result of that, the group has decided to set up a center of excellence, which would with that purpose, so to use the data, to gain these capabilities, and then to serve our operating companies and to help them to become really data-driven. As I said, remember, we are talking about companies like Zvijezda here in Croatia. It's 100+ years old company. Konzum, Croatia, 60. Mercator, Slovenia, 70. So we want to have a central place on which would help these companies really to use this data in decision making. We are not the first to come up with such an idea. You can see here many global companies in the last decade or couple of years before us. They started with these global retailers here, but some other also started with this approach. I see some familiar faces, so hi to everybody here. These companies went that path. So did we. What did we create as a mean to reach that strategic goal? We created something we call Fortenova Group DataLab. It's a place which has an organization, basically, which has 3 missions. First mission is that we want to generate value by using data and latest technology. So we want to have a latest technology, which currently means using cloud technologies on which we could collect all the data from various data sources. We could clean the data, obviously, reshape it, merge it together, create something which we call data products, which is then available either for direct usage for our companies or to apply machine learning or artificial intelligence methodologies directly on that data. So, and we want to build these capacities in our platform. We have selected Google Cloud platform to be a technical platform for our purposes. Then, throughout the group, we want to build a data-driven decision-making culture. So really, to implement these findings, not the data, but the information and the findings that we generate from the data, almost in a factory mode. So really create a lot of information to implement it in the business processes. Like I said, in daily business processes or not so frequent business decisions through the usage of machine learning-based recommendation tools, dashboard visualization, or something specific, ready-to-use data cubes, data chunks of information, APIs, I don't know, whatever, right? How do we want to achieve that? We want to basically to build these analytical solutions, tools, tool sets, and so on through cross-functional teams in an agile manner, which means always have somebody from the business so like we are today, basically. I'm more maybe from a business perspective, business side. Martin is more from the science. And then we always work together in order to develop such solutions. Here are some of the topics, and it was very interesting, previous presentation, very interesting, so we can see that somehow we fit together. Some of the topics that we want to address with this data-derived information. So how to set up, what is the best assortment, I don't know, here in this neighborhood for these people that live here or the people that work here. So we know that in our business we have limited space and the price of the space really is going up. So it really is very, very important that you have good return on this investment. So how can you do that? You can, beside a good service and so on, you can offer really tailor-made assortment for that location, right? So you can then work with the prices to have good perception, to be profitable, to understand the price elasticity, to define the best marketing mix that will give the best return. You can try to boost productivity in your operations, supply chain operations, try to analyze the demand patterns, organize the workforce. Remember, we are really, again, I'm repeating, traditional company with really huge workforce. We have, we saw there 45,000 people, how to schedule, how to create, I don't know, good shifts that are fair to everybody. And so many problems which can be tackled and solved much better with the usage of these methodologies that we are talking about today. So currently, in this project of Fortenova Group DataLab, we are focusing at this moment on these three topics. So define good promotions for our consumers, define good assortment, and be efficient in the supply chain. We will see one use case from the supply chain domain. We have these projects in Slovenia, not all of three in all of three countries, but some of them in Slovenia, in Croatia, and in Serbia. So we really wanted to start immediately on most important markets for us to gain the value on all of these markets for all of these companies. The use case that we are going I'm going to talk about motivation, and Martin, he's going to show how did we tackle this demand forecasting, is fresh food. It's obvious why we want to understand the demand for fresh food, because we believe there is a value there in a sense that we can trigger much better operation and at the end provide better quality, better availability, better service, which would then benefit us with results. So it's not an easy task, it's pretty traditional problem, I must say, compared to what we saw today, but still not an easy one to resolve, and especially not an easy one. Imagine if you are a lady, usually we have the female colleagues working in the store, and then in Konzum, this use case is in Konzum, Croatia, so it's 600 stores, thinking about hundreds or thousands of items, and then try to order for, I don't know, 5 days, 7 days ahead. If we want to buy from producer, then we need to have forecast for 90 days ahead. So it's really not an easy task when you consider what is affecting this demand, right? So seasonalities, prices, promotions, competition, weather. When it's cold in Zagreb, nobody goes to market, they go to the stores. When it's a nice day, people love to go to markets. Then we have some events that are affecting, I don't know, some concerts or soccer games or something similar to that. So it's really, really not an easy task. Luckily, we have majority of this data available, and Martin, he's going to show how we use it to tackle this problem. I'm just showing here a couple of interesting examples. It's the same product. Again, it's pretty traditional business, so the product is banana, but one store is in Zagreb, the other one is in the island of Krk. You can see the patterns here, right? So in Krk, obviously, summer season, you have the peaks. Here you have a saddle, so it's the opposite seasonality. Here we had the pension day. So in Sarajevska, it's New Zagreb, our customers in that area, neighborhood, we have a lot of guys, elder people, let's say. So they use this opportunity. It seems like in Krk they don't use that opportunity. Then here we had really some significant promotions. So much more, I would say this location is probably more price sensitive compared to this one. So what I want to say is basically it's an item specific, store specific. The data is sparse. We have tens of thousands of items, thousands of stores, many, many days. When you multiply all of this, it's billions, really, billions of problems that you have to solve. So really great place to use machine learning. And we saw today, we have to, especially we are not a researcher. Martin is a researcher in his academic career, but here in our roles here, we need to create business value, right? So we need to analyze what is the impact of our ideas, right? And in this use case, if we achieve less out of stock, less wastage, we will have more revenue, more margin, satisfied consumers, even satisfied workers. Nobody likes to throw away the food. This is one side effect which is not nice from the wastage. And on the other hand, there are some other effects which are also really interesting, like controlling or let's say be more productive, have a lower cost of operations as a result of better planning in the operations or better planning with our suppliers. So altogether, let's say that this means that this use case is qualified for us to invest in it and then to use this data lab, all of these people that we are building up their capabilities together with our partners to tackle this problem because we think we can generate the value for us, our customers, consumers, shareholders, and so on. And partners. So how did we tackle this one? Martin, he's going to present this. So the floor is yours. Thanks.
Thank you. So now we are going to learn how we use machine learning to upgrade demand forecasting first in Consum, and now we're also starting in Mercator. Current approach. So here in these two tables, you can see algorithms that are currently used in both companies. The first rows, underlined rows, you can see these two models are used most commonly. And both of these methods come from a family of statistical methods for time series forecasting, where you basically just take past data, you take store skewed past data, and forecast the future. And this principle does not work everywhere. That's why you need several methods. Like in both cases, you have separate procedures, separate methods for promotional forecasting. And so we decided that we would like to achieve these 4 points with our machine learning model. We said we want to have only one model for all SKUs, for all stores. Why? It's much easier to manage it. We would like to use also additional data, not just past sales data, because we expect such a model will be more accurate. We would like to have a model that's capable of predicting promotions, regular sales, or any kind of special events that can happen in this time. And the fourth objective is that we would like to have a model that can predict several days in advance, which is not that trivial, as you will see. When I talk about additional data, I'm not talking about starting collecting the data, but retailers really have a lot of already collected data. We have data that comes from business, just doing business. We have past and future data of past decisions that we did. We have all sorts of data describing items, stores. We have data that come from external sources. So we are collecting weather data. We are collecting prices from competitors. All those kind of data that you see here, it's already in our data warehouses. The challenge here is how to put this into a machine learning model to improve forecasting. And this is solved by creative feature engineering. When you talk about this basic machine learning concept, basic machine learning idea, you will usually have some instances, or maybe we can call it problems or inputs. And from these inputs, you would like to predict some outputs. In our case, what is an input? You have a product, we have a store, we have a certain day in time, and we would like to know what is the demand going to be, let's say, in 3 days. That's our input and output. But to make this model effective, what you need are clever features. Features are describing our problems, our instances. And with clever feature engineering, you can solve all 4 problems or 4 objectives I have mentioned before. So if you want to have one model for all stores, what you do, you have to include features describing stores. If you want to have one model, want to have a model that learns from additional data, just construct features from this additional data. If you want to have promo forecasting, just add promo features, so like promo price or promo type. And the 4th objective, so doing several days, forecasting several days in ahead, that's a bit more tricky. Let's go into it a bit more deeply. So here I have an example of a time series, just past selling values. We are at this point here, and we would like to forecast the next 90 days. As we have seen in the previous slide, machine learning models in this basic form are able to predict one value. How will you now predict 90 values? There are several approaches. So one of the most common is it's called recursive. Basically what you do, you say, okay, I will forecast demand for the next day. Then I will move, forecast the next day, move, and do it 90 times. Or you can say, okay, if I can predict one value, why don't I just have 90 models? I will use one model to predict tomorrow, one for the day after tomorrow, one in 10 days, and so on, 90 models. It solves the problem. So we didn't go with these 2 solutions because, again, we would like to have one model. It's easier to manage that. So what we said, okay, what if we just add a simple feature having the value horizon, so how many days in advance you are forecasting, in the feature set, right? It's much easier to manage, but it's a bit tricky because such a model is much harder to train. However, it works. So when I talk about features, why is that so important? Because where does this feature come from? Yes, of course, in the end, data scientists have to implement that. But data scientists don't know which features to use. So the knowledge which features to implement must come from the business. And that's why you have probably seen such abstraction of this machine learning process going from problem definition to production many times. But everyone that has ever been in this process knows that when you go this way, it's not just one-way path. It's more like something like that. Because each time you come to evaluation, you start looking at the model, and you will pinpoint some critical areas. You say, okay, but my model is actually failing for this in these cases. In our case, the first problem was that we were not able to model weekly seasonality wells. How do you solve that? Well, you have to, again, add some new features. Features that will solve this problem. And then you do this again and again and again until you're satisfied with the model. But what's really something that turned out in this process is that this way of working fits very well with the agile way of working. In agile way of working, you have to deliver something every sprint. And every sprint you have to have a new model. Every sprint you have to talk to business experts. And in every sprint, when you talk to business experts, you present them your model and present your problems. And you will get ideas from them for new features. And those features are much more valuable than those features that you just think of yourself by just looking at the data. I mean, I have been in many projects, and I have seen other projects where data scientists would just work on a problem for several months, and in the end, when the deadline was coming, say, okay, maybe now we should talk to the business, but that's too late. Here, you force the business to talk to you, and you force yourself to talk to the business. And that is great. But there is one trick here, that the business has to realize that. That the business has to realize that you're not just producing the models for them, and they validate it, but they are building the model with you, right? And the first models that they will receive will not be that accurate, not at all. You will be here at the first step, and you will have many problems, and the predictions will probably be bad, but they are there to help you improve that. Okay, so let's say that we do this many times. We have come to a good set of features. We are satisfied with the model. Let's say this is it. Now it's time to evaluation. We will evaluate our models always in several steps. First step is historic evaluation. What you do, you just move in time, do your predictions, simulate what would happen, and see how accurate is your model. And in this way, you can compare it to the model that's already in production. So when we did that, we did that for several categories of fruits and vegetables, calculated the map, which is just percent error, and we've seen that our model is consistently outperforming the current baseline model. And that was the indicator, okay, great, let's put this into production. Okay, so for integration, we're using mostly Google Cloud tools and Python and XGBoost library for training the model. Here we have our solution stack for forecasting. For the forecasting phase, basically at the beginning, you just start with dbt and BigQuery to define features. Then you load the train model from cloud storage, put everything into Vertex AI on many machines, wait for results to get, and at the end, aggregate forecasts again here in a table, which is then ready for investigation by domain experts, or you can simply just use it in the replenishment process to generate orders. Okay, so now we have this loop. Every day you run these forecasts. Your model is in production. What now? You have to monitor it. And that's the second layer of evaluation. Because now you have to check that your model is not doing something stupid. Now it's going for real. And here what we have, you have a dashboard implemented in Data Studio with measuring several KPIs, such as we measure how accurate it is. Like Adrian mentioned, out of stock, wastage. We would like all this to go down. Accuracy we would like to go up. And here is an example of another KPI, which is a directly measurable KPI. What percentage of proposed orders that were calculated from our forecast are directly accepted in stores by store managers. So with previous model, it was 60%, and now it increased to 85%, which is quite good results. Now, I have to admit, we are really in early stages of the pilot. We started with 1 store. We are now with 10 stores. So these results here are not really conclusive. Probably we could give you more final results in 1 year on the next conference. But for now, it looks good. Not just with this KPI, with every KPIs. Okay, so what did we present you? Basically, you learned about what DataLab Fortenova is. It's a center of excellence. We would like to mention that we are building a very nice data science community. We use state-of-the-art technology, and if you ask me from a data scientist perspective, the most important thing here is that your work actually can have high business impact. You can see that whatever you do, it will be reflected in the business. At this moment, I would like to also mention that we are hiring. So we are looking for data scientists, data engineers, DevOps, product owners, everything. If you liked any of that, what we showed you, please, you're very welcome to apply. So this is the moment to stop. Thank you.